I hope you are all excited and ready for a day of learning and contributing to the foundation of observational research. This is important stuff, right? And we need to learn how to do it as well as we can right now, and we need to accelerate our progress towards doing it better in the future, right? And we have an outstanding faculty to guide us. They are busy doing various things, as they have been over the previous several months. They are thought leaders and developers of innovative solutions for organizing information about data quality and tools that assess them. And our main goal here today is going to be to make sure you understand the frameworks for organizing that data and for how to install and use these tools and use them. And you're going to walk out of here knowing how to do that. The people involved have put in a lot of time. So Michael Kahn in the back of the room is going to be leading us off. He and Tiffany Callahan, who's not here, is one of the lead author of one of the papers he's going to be covering. We've got Wojtek Husser, who's talking to my colleague Robert Miller over there. Wojtek's familiar to many of you. And Ajit Lond, who's been working with Wojtek and building new innovations into Achilles and doing other work I'll describe in a bit. We have Hania Razagi and Connor Callahan, both from CHOP and part of PedsNet. They're going to be displaying the PedsNet toolkit and describing how it's been used in that community. We've got Tim Berquist here, who's been working with Hossein Histiri, who developed the tool that Tim's going to be showing us about. And other people who aren't here have also contributed to that, Carrie Stevens among them. They've all been working over the last few months to develop this tutorial and making changes, substantial changes in some cases, to things, and they do it on a volunteer basis. They put in a lot of time and effort. They're leaders in this field, and just join me for a second in giving them a hand for all of that work. There's also thanks due to the data set that you're going to be running the tools against. That's the MIMIC data set, and the folks who are partly responsible for developing and sharing that from MIT were here yesterday. Two folks were, Alistair Johnson and Tom Pollard. I hope some of you got a chance to meet them and help them understand how awesome the OHDSI community is, and so that PhysioNet and all the things they're doing with MIMIC and that framework are more and more closely joined with what we're doing. I think they're a great group. And finally, the same folks that got a lot of credit yesterday should get credit today. So Maura Beaton and Elise Katzman and Patrick Ryan and John Duke and George Ripsack also did a huge amount to make all of this possible. So they deserve our very sincere thanks as well. And we are very interested in starting off in understanding what brought you here. So I'd like a couple of volunteers to just raise your hand and let us know why you're here and what you're hoping to get out of it. So who's willing to share? Who else can tell us a little bit about what brought them here? Who else wants to? Anybody? It's okay. We want to move on.
Can you tell us who you are?
I didn't do that, did I? I'm Andrew Williams, and I work at Tufts. I got involved in this work through the Electronic Data Methods forum that Academy Health sponsored, and that was the seeds for a group that's really worth checking out, the Data Quality Collaboratory, and it spans different networks. It's a group that Michael Kahn ran for a long time and is now being very ably run by Meredith Zosas and Nicole Weisskopf, and I strongly urge you to participate in that. Anybody who's interested in participating in it. There's a lot of wonderful ideas that are presented there and demonstrations of approaches, and just it's a great space to kick around thoughts and approaches for this complex set of issues. And anybody who's interested in participating, please contact me or Michael, and we'll make sure that you get added to the list for that. I did. Oh, yes, I did. I was the person who sent you that email. Hopefully everybody got that email. And so I'm at Tufts. I've been at other places, but I'm not going to go into too much more about that myself. I am a person who understands the quality, the importance of data quality, and I'm trying to make sure that we as a community are taking advantage of all resources that we have available to us and push that activity forward. That's really the gist of why I'm here. But you are an extremely, having reviewed the the list of folks who are participating, you are an extremely impressive group, and there's a lot of talent and knowledge in this room, and a lot of experience that we're going to be actually hoping to draw on later in the day here. But for now, I'm interested in participation in networks. So obviously, everybody's got some affiliation with OHDSI, but this is a set of issues that affects many different networks. If I could see a show of hands for who has some role in PCORnet. Nice, very good. And who's got some role in Sentinel? Anybody in Sentinel? Excellent. And who's got some role in the HCSRN? Similar group, very nice. Maybe that's where we know each other. It's possible. Any CTSA hub whatsoever? Nice. Eden, folks involved in the fantastic European network to be. Eden, anybody? No? I think Dimitri was going to be here from Odysseus. He doesn't seem to be. I think would qualify there. How about FeederNet? Anybody in the new fantastic Korean network? Any other networks that people are involved in? All of us. All of us is a good one. Who's involved in all of us? Here we go. Excellent. All right. So this is a huge challenge. Any of these networks are faced with a huge set of challenges. That's a striking yellow background. Who knew? It's a huge challenge. And yeah, I've already pitched the fantastic data quality collaboratory call, which I plan to do. But the focus today isn't on all of those different networks. It's on OMOP and the OHDSI network. And the topics today will focus all on tools that are designed to run against that. But we are going to have a segment later that Wojtek's going to lead that's there's a very comprehensive new data quality program. It's been published by the Sentinel Network, and we are today going to be launching an effort to learn as much as we can from that. That's what the OHDSI does. We kind of learn as much as we can from the entire world of folks working with these things, and then we share back everything that we produce and give. So we'll be doing that, but trying to leverage the excellent work done in Sentinel and led by our colleague Jeff Brown. And later on, Wojtek will be presenting on that, and he will end with an inspiring, almost irresistible call to arms to join us in that. And so look forward to that. Let's see. Yeah, and the other ways in which we're going to draw on the expertise that you all have, we're going to have a data hacking session or a rule hacking session later on. So you'll be hearing about the different rules that are used by the tools that are implemented here. And at the very end of the day, we're going to be asking you to make suggestions. One of the things you got in the email from me this morning was a little form that allows you to just, if there's a data quality rule and you're not sure it's covered by one of these tools, now or any time in the future, you can just get in the habit of submitting this. And another thing we're launching today is a effort to curate those rules and then make them available to be added to these tools. We need an ever more comprehensive set of tools to work on this. And so there's been an excellent leadership for this, lots of innovation in implementing these things. I think we are at a point as a community where we need ever more support for that. And so this is a means that's going to be allowing us to add to these things and covering data better and better. The agenda is straightforward. Michael is going to lead off with a description of a harmonized data quality framework for organizing facts about data quality and covering the paper by Tiffany as well that I mentioned. He's going to have a brief introduction to each of the tools. We're going to get you all logged on. I think you should have, anybody who did not get or has not yet checked to see if they have the email that I sent out this morning, could you raise your hand? Do you have a means of checking your email now? You can? Just check and make sure. Let me know if you don't. That's got some things in it, including your user ID that you're going to need to log on. So please go ahead and make sure you do that. We're going to go through a demonstration of how to run each of the tools, and that'll spill over into the afternoon. The rest of the day is going to be covering topics, some of which I've mentioned. One that I didn't mention is data sharing. And we, in general, we want not only to understand the data in our own network, but to be able to benchmark it against other similar institutions and understand how a whole network's data or how a collection of sites that might be involved in the study, how their data support particular use cases. And so there's all kinds of issues, sensitive issues that institutions have and complex technical issues about how to do this in acceptable ways that are involved in data sharing. And PedsNet's done some really fascinating, important work in this area, and both Wojtek and Hani are going to be talking about that. As far as breaks go, we're going to be playing it by ear, seeing where they fit into the solution, where they fit into the schedule naturally. And I think everybody knows where the bathrooms are. Is there any questions before we leap into the schedule? No? Is everybody still excited?
There's a break in the middle of the morning session, so I think, is there coffee all the time or just during that break?
I don't know the answer to that, Wojtek. It's an excellent question. I will try and find out, but I think there is a break, and I think, as per your suggestion, we were going to be a little bit flexible about when exactly we took that break, but I will try and make sure that coffee is available, as it is essential to all of our well-being. All right. Yes, there's a question.
I don't have an email.
You don't have an email? Okay, I'll make sure. Okay, I'll come just make sure you have that. I'm terribly sorry. I don't know why that happened. All right, and without further ado.
Hey, welcome everybody, and good morning. I am Michael Kahn. I'm from the University of Colorado. I'm a faculty member in the Department of Pediatrics there. I'm also a member at Children's Hospital of Colorado. And that's an important point from my first couple of slides. Remember that the databases that I use come from an institution. The only thing that they see are children. That will be an important point. We do not see adults at Children's Colorado. Some of you have seen some of these slides. I apologize. I see some faces who have seen these slides before. It's the same jokes. I'm sorry. So one of the things we want to start with, because the whole day is about data quality, is sort of what is the language that we use to talk about the elements of data quality. It's a complex, sort of multi-axial beast. And the language in the literature, the language that's out there, is really quite confusing and very disorganized. So I'm going to give you an example, again, reminding you I come from a pediatric hospital. We see no adults. But our EMR says we have some 6-year-olds in our electronic medical record who it claims that 76 of them are married. 3 of them have significant others. 2 are already past that and divorced. 1 is just legally separated, so kind of on the way. And for, in a children's hospital, we have 40 for whom we do not know they're married, 6-year-olds whom we do not know their marital status. And this is real data that is in our database. I keep doing this query every year just to see if we've gotten any better, and we don't. I do this query over in the adult hospital, which does see some pediatrics, and they have the same problem. But the issue for you guys right now is, what word would you use when someone came to you and said we had this problem in our data set?
Normal.
Data entry.
Okay, normal. That's some states in the United States. I get it. Let's take it. Okay, congruent.
Unreliable.
Unreliable.
So scientists come to me and say, this data is really dirty, and I would say, oh, you mean it's data.
It is. So you've given up just it. So some of the other words that people have used, and we heard some of them here, is calling this situation sort of an issue, a data quality issue, data validity, data accuracy. These data are not accurate. Trueness. These data are not true. They're not believable. There is someone sort of got to this idea of consistency. I expect sort of this age versus marital status to have a certain pattern. It's not consistent with that pattern. And again, you've even given some other words, including I give up, it is what it is. And this is the problem in the literature, and this is why reading about data quality and trying to figure out what should I do, which of these things do I want to do, is really difficult. This is, a slide you're not supposed to read, but here are, I went and did a literature review to kind of see, well, how have people organized, again, this multi-axial, multi-dimensional beast called data quality. And here are 13 different frameworks that have been published, specifically in the healthcare field. I ignored the information technology field, which has their own similarly 13 different ways. Somewhere in the middle is this guy named Khan, who contributed to the chaos himself. I put something out there about 6 or 7 years ago. And what makes this hard is when you're reading an article, you're reading someone's either findings, what are they finding, and or what are they proposing as a data quality framework. You don't know how to put it into anything else that you've seen, and you don't know how to put it into what you are doing. Sort of where am I on this landscape of data quality? And so, you heard a little bit about the Data Quality Collaborative. This is a group of the willing. These are people who sort of struggle with these ideas, who choose to get together second Thursday of every month at 3 p.m. Eastern. And people just come and sort of either present what they're doing or present what they're struggling with and try to get input. So sometimes we get some previews of a presentation that's coming up. Sometimes we get a presentation that was given in a conference previously, and then we get to drill into what does that mean to me? Where do we find software? So again, invitation for all to join. It's an open webinar of the willing. It's the usual, OHDSI model. So what we decided we needed to do is we needed to sort of take these frameworks and get out of this, your tomato is my tomato, and sort of figure out how are we going to kind of come up with a language, merely a language for being able to sort of say, I'm working here in the data quality landscape. No, I'm working over here in the data quality landscape. Gee, we have nobody doing any work over here. We needed to decide sort of the landscape. And so this is what we spent almost 2.5 years. It was an arduous, is the nicest word I can think of, process to really herd the cats. And the issue is you want to really make sure that you align the things you can align, and you don't try to align things that sort of have no representation somewhere else. So it was really sort of getting everybody sort of moving in the same direction. So we, on the course of today, will be talking about 2 of the work products that came out of that effort. Both of them are available, open access, on the eGEMS website. So these are freely available, and I can send them to you if you wish, or you can go download them themselves. These slides will be made available, so the URLs will be made available to you so you can have those. But for this morning, we'll be talking about the harmonized terminology. Later on in the day, we'll be talking about the data quality reporting recommendations and how that links into some of the data annotation and metadata work that's happening here. So again, it was arduous, tedious, and there were moments of misery in getting everybody, because people really held on really strongly to the terms that they want. And we had to be very careful. For those of you who work in the psychometric field or work with people who work in psychometrics, these are the people who do surveys. That community has really has very strict operational definitions of the words precision and accuracy. They have very strict operational definitions, and they were different than what we felt we wanted to use for data quality. So we had to avoid words that came with meanings from other fields, and so we had a little bit of language landmines that we had to deal with. So this is the one that we're going to be talking about today. It's the Harmonized Data Quality Assessment Terminology Framework for Secondary Electronic Health Records. And it's important because I'll end this slide asking a question for any students who are out there, or any of you who have a student who might be interested in this area. This work was limited to electronic health record data. We make no claims about its applicability on the genomic side, sort of on the instrument side, on the Fitbit side. We make no claims that this framework, but I'd love a student ask the question whether it does. So I'm going to skip across the pond very quickly about what this framework looks like. So the framework divides the world of data quality into 2 sort of camps. And it's really based on where do you go to find the expectations of what the data should look like. And verification is basically when you're working with your own data. Only your own data, you're sort of in your own institution, and you're not integrated with external data sources. So the expectations come from, what do I expect in my world? For example, in my pediatric world, I have expectations of the data that look different than someone who's working in a nursing home. So those expectations come from you, whereas validation is when you start to bring in external sources of data to help sort of validate what your expectations should be. So if you think a little bit about what Achilles is, as right now, Achilles operates on your data only versus imagine a networked version of Achilles. key leaf, where we're sort of maybe doing my data versus everybody else minus me data. That would be more in the validation world. So we broke up the huge landscape. We took all those various dimensions of data quality, and we really kind of made it as simple as we possibly could. And we really developed sort of 3 stacked layers. By stacked, I mean you start with the first one. If you can't get past the first one, don't even bother with the second one. And if you can't get past the second one, don't even bother with the third one. So completeness is just basically asking the question, are the data here? Some of you will use missingness as the word. I guess half glass half empty, glass half full. We use the word completeness. And just, are they there? And at that moment, you're really not asking, whether or not anything else about it. Fidelity are asking whether or not sort of are they dependable. At this point, you're not asking about believability of them, but do they align as expected? And you'll see what that means in a second. And plausibility was the word that we ended up sort of compromising with to get away from accuracy or precision or these other words that came from psychometrics that had really different. So we kind of said, well, let's use a one that hasn't been taken by somebody. Let's steal plausibility. And that is the believability of the data, not necessarily assuming that there's an absolute, cosmic truth out there, but that there's some expectation of what the real data should be. 3 levels. Completeness. You don't have completeness, don't bother with fidelity. You don't have fidelity, don't bother with plausibility. And so, again, skip across the pond. We're not going to delve into this. It's really mostly just to introduce you to this. In the article that you can have access to at eGEMS, this is how it's laid out. Again, the 2 worlds, verification, my data only, validation, I've got something else to look at, something else is driving my expectations. In terms of completeness, we really put it into a sense of density. How much data are there that I'm expecting to be there? And there's a temporal part of it and an atemporal part of it. So if you have some time-varying stuff and you expect so many points per quarter, per year, you go into the temporal side. The other is just atemporal. Again, not expected to read this, just to give you the flavor. On the fidelity side, there are subdivisions, metadata, sort of do the data even follow the data model standards? And do they have the value set compliance with what they're supposed to be? If you're supposed to have M and F, you have a Z in there that you're not supposed to have. And then there's about things about the fidelity of the measures. If you have derived variables, are they being derived appropriately? And then uniqueness, if you're only supposed to have one of something, is that happening? And then we give examples and more definitions about what that means in those dimensions. And then finally on plausibility, we talk about sort of the plausibility of the measure, and then we bring time back in again. And especially in healthcare, time is so critical, and sort of understanding sort of the temporal progression, and therefore we needed to explicitly call out quality measures, quality dimensions that really sort of called out time, temporal parts of medicine. I want to just bring up this diagram from Griffin Weber from Harvard to remind us, however, this is leading into my pitch for a student project. So I only have one more slide, so that's where we are. To remind us that, we collectively mostly live inside this little T right here. This is, for the most part, of the world of possible data elements that might be useful in determining the totality of a person's health and wellness, moving a lot more into wellness now instead of illness, and the environment and the risk factors, and again in pediatrics, looking at lifelong exposures that lead to adult diseases, and now we're even moving to perinatal exposures leading to lifelong diseases. There's a huge world out there of other kind of data elements that I suspect some of you, and likely in coming years, most of us, instead of all of us, most of us will probably start to use wearables and mobile device data and other kind of forms of sensor data that come in. I already know some of you who are mining social media for trends. So just a reminder that while this data collaborative worked on electronic health records and spent 2.5 years trying to understand how we were going to organize our thinking on data quality in that little T, There's still a whole big world out there. And so I don't know the answer to this question as to whether or not this is a sufficient framework that allows us to also talk about data quality in the context of all of these other data sources that, again, some of you are probably already dabbling in, and most of us will probably be significantly invested in the next few years. And so, blatant, advertisement that there is a student project waiting to be done by somebody that this actually isn't, I forgot, I have Tiffany's slides, Andrew, I'm sorry.
That's all right.
Waiting to be done, love to have a student. But one day I want to switch gears and say, okay, we have this framework, nice work, very good. But let's use that framework to ask the question, there's people who have done work in data quality, they've published their work in data quality. Some of them have even put their data quality rules out there on the website. Others you have to kind of negotiate with. So Tiffany Callahan was a student of mine who has now gone on to her PhD, who helped me ask the question, well, of the stuff that we could get hold of, what are people measuring against this framework? What's actually happening out in the field? So we were able to wrestle, control, guilt works really well. Data quality rules from 6 networks. Caesar is the Kaiser Quality Network's extension of the HMORN. Murdoch is a very large clinical trial, observational clinical trial. OHDSI, so this was the then current state of Achilles. PEDSNet, which you'll hear from Anya a little bit later. FIS is the Pediatric Health Information System, and Sentinel a number of years ago. And something you can only ask a student to do. Tiffany looked at every single one of 11,000 data quality checks, and we ended up doing this about 6 different times. So there are moments when she wanted to kill me. And we tried to sort of put each one of them into this matrix of this rule goes here, this rule goes here, this rule goes here. What are people doing? So just to show you the overall view of the world, what you can see is a very predominant about atemporal plausibility. And basically, these are range checks. These are means, medians, this kind of stuff. And what you also get a sense of is time isn't looked at very often. Time is right here. First temporal one is right here. So time still remains something that people are not paying as much attention to as we think they should. But this is what from those 11,000 checks what people are doing. Again, at that time, the world's moved. And one of the other things we wanted to do, and we're not claiming what is the right answer or what is the best. This is well, you can't see it because it's not in color, so I apologize. When you get the slides, each one of these dimensions have a different color. But you can't appreciate the distribution. And the point here is they're all different. They all are spending their time, effort, focus on data quality in different parts of the roadmap, the landscape. And again, we're not saying that there's a right distribution of data quality checks that you should be doing. You're driven by your use cases, you're driven by your data sources, you're driven by sort of the concerns of what you're trying to do. But they're all different. And I don't know if there's an optimal distribution, but we just wanted to lay out there that there are these differences. And wouldn't it be nice if we could get to the place where we could take all of those data quality checks across the whole landscape, because collectively they cover more than what any one of them are doing. Moving over to PEDSNet, Anya, I'm sort of stealing some stuff that came out of the work that you did with Ritu. PEDSNet published a paper in the Journal of American Medical Association. I can't remember. Did you guys make this open access? Did you make the PEDSNet DQ paper open access? Did you pay the?
I think so. I think it is open access.
You paid for it.
I think it was sent out to people as one of the suggested readings, I think, this paper.
Okay. So PEDSNet is 6 academic pediatric institutions, all freestanding pediatric institutions who form the network in the PCORI network system called PEDSNet. And this was their assessment of the types of errors in the rule checks that they were doing. And you can see the dominant line here is missing data sort of dwarfs sort of all the others. This is an absolute number, but you can see that clearly is the highest one. But this is actually the more interesting one, and of course you can't really see it because of the colors. I apologize again. This is colored. But what it is showing, just unfortunately conceptually, is this is the number of ETL cycles that the network was doing. And what they're trying to show is, did the mix of data quality problems change as the network got more mature and figured out what the heck it was doing and nailed more specifically some ETL conventions? We are going to do it this way. We are going to do it that way, and try to nail some of the uncertainty. And this is, again, what OHDSI is doing now with the Themis group, trying to nail down some of these conventions. And what you can't see in color, this is good for the colorblind males, right? This is what their world looks like. Is right here, if you follow this bar that's going progressively down, this is the programming errors. These are the ones that are caused by a misunderstanding, by an ETL specification that was vague, was applied differently, and over time we realized, ooh, we need to be specific and write down this convention. The conventions document for PZET now is over 80 pages. And what you see growing, relative proportion, this one here, is ones that are what the word that is used in PZET is called characteristic. What that means is the data just are the way they are. We can't do anything about it. This is how they come to us. We can go back and guilt trip the source system, but there's nothing that we can do ourselves. And so what you see here is a lessening of the kind of issues that we can handle at the extraction team, ETL team, and the growing proportion of stuff that we've got to partner with our source systems. And so this is, again, showing the maturity of a data quality environment where we're getting better at how to do the extraction over time. So one last little bit, because I see Andrew giving you the evil eye. Yeah, right. Now we're talking about terms at this point, and the rest of the day is all about measures, right? So it's important to know that the way that you go from terms to measures is by computation, and this is what the tools are doing that we're going to use today. We're going to compute measures that come from various different parts of the data quality landscape. And so it's really important, and this is one of the next areas of research in data quality, is to make sure that we harmonize on the computations. Because if you compute something differently and call it the same thing, it isn't going to be the same thing. So we have to make sure that we make the, sort of tie in the way in which a measure is computed, in addition to the label that it gets. I'm not going to get here. One last little bit. Okay, we do not want to do that. This motivates some of the work he's doing. One of the problems with the current state of affairs in data quality is every tool does it differently. Every tool stores its intermediate results differently in a different data model, and they then tie all the reporting systems against that results data model. And it's stuck. You can't do anything about using someone else's tool or somebody else's rules because it only works against their native data model, stores in their native results data model, and the reporting out of that data model. And what we were looking for and hoping for a world that looks like this, and Wojciech is one of the leaders in this, and the data annotation group, is really a world in which we in fact standardize on the data quality assessment results common data model. Those data, and then if we can get there, where you can then all use each other's tools and rules and stuff like that and be able to share that work. We're not there. This is still future work, but we're starting to see this evolve. And that is it. Sorry for going into your